Then a machine cuts the pipe end to a specific angle. This is called beveling. That angle cut is very important. It is what allows the welder to get the weld metal all the way through the pipe wall. Without that bevel, you cannot make a proper weld. You will only fuse the surface, and a surface weld on a subsea pipeline is not acceptable. Now the pipe end meets the end of the pipe already in the firing line. The two ends have to be lined up perfectly. There is a tool called an internal line-up clamp that goes inside the pipe and holds both ends in position. The gap between the two pipes, the wall thickness alignment, everything, it all has to be within very tight tolerance. Before welding start, the pipe is preheated. Why? Because steel does not like sudden heat. If you weld a cold pipe, the heat from the welding causes stress in the metal. That stress can lead to cracking later. So you heat the pipe first slowly and evenly to prepare the steel for welding. Once the temperature is confirmed and it is checked with a temperature gun, not guessed, welding begins. Station 1 puts down the root pass. This is the first weld bead that actually joins the two pipe ends. It is the most critical pass of all. If the root pass has a problem, every pass on top of it inherits that problem. Station 2 follows with hot pass. This builds on the root, adds more weld metal and starts filling up the bevel. Here is something interesting is happening. An ultrasonic probe is being moved across the weld. This is checking for slag, small pockets of non-metallic material that can get trapped inside the weld metal during welding. You cannot see slag from outside. It hides inside the weld, but it weakens the joint. If a problem is found at this stage, the work stops. The joint is cut out, you start again from the beginning. This is standard. There is no negotiation on weld quality in this industry. The pipe is now moved to the third welding station. The earlier passes fill most of the bevel. The work at this station is to complete the fill and put down the cap, the final weld pass that you can actually see on the outside of the pipe. Between each weld layer, the surface is cleaned. Wire brushing, grinding. This is not just tidying up. Each layer must be cleaned before the next one is deposited. Otherwise, you are welding over contamination, and that creates defects inside the joint. When welding is finished, a visual inspection is done. An experienced inspector looks at the weld profile, the surface finish, the consistency of the bead. A good weld has a certain look. A trained eye will spot a problem immediately. Visual inspection alone is not enough, but it is a good first filter. NDT, not destructive testing. This is where the weld is examined without cutting it open. First, ultrasonic testing. The probe scans the weld from different angles, sending sound through the full thickness of the pipe wall, looking for any internal defects, cracks, porosity, inclusion. two methods. One covers internal defects, the other covers surface defects. Together they give a very complete picture of that weld. Now someone has to read the result. The NDT technician is looking at the data on the screen. Ultrasonic testing does not give a simple green light or red light. It gives a signal trace, and a trained person has to interpret that trace. This is a small detail, but it matters. Before the pipe enters the tensioner, it is cooled again. The tensioner grips the pipe and controls the tension in the pipeline as it goes over the stern and down to the seabed. The gripping surface of the tensioner, called shoes, are made of rubber. Hot pipe and rubber shoes do not go well together. High temperature damages the rubber and reduces the grip. So the pipe is cooled to a safe temperature before it touches the shoes. Small details, big consequences if ignored. The weld has passed all tests. Now it needs to be protected from corrosion. But first, all the dye penetrant residue has to be removed. Any contamination left on the steel surface will affect the bonding of the coating. So the cleaning is thorough. Then the pipe is heated again. This time not for welding, for coating. The heat shrink sleeve that is about to be applied needs a warm surface to bond properly. The adhesive on the inside of the sleeve activates with heat. If the pipe is too cold or too hot, the bond is poor. On a pipeline that will sit on the seabed for 25 years, a poor coating bond is serious problem. The heat shrink sleeve is now applied. This sleeve covers the weld zone, the area that was bare steel after welding. The pipe body on either side already has a factory applied coating. This sleeve bridges that gap and completes the corrosion barrier. The sleeve is wrapped around the pipe over the weld area. Heat is then applied evenly around the full circumference. As it heats up, the sleeve shrinks and conforms tightly to the pipe surface. The adhesive melts and bonds. The sleeve becomes part of the continuous coating system. That sleeve is what stands between the weld and the seawater for the life of the pipeline. Automated ultrasound now checks the sleeve application. It is scanned the bond between the sleeve and the pipe surface, looking for any area where the adhesive has not properly bonded. Foam coating is applied at the filled joint. What you are watching here is that process. A sheet of foam material is wrapped around the pipe at the joint and secured in position. Then, through a small hole, a foam compound is injected into the space between the wrap and the pipe. The compound expands, fills the space completely and sets hard. This makes sure that the seawater never penetrates down to the raw iron pipeline. Now the pipe is ready to go overboard, but before that, a laydown head is attached to the pipe end. This is a flanged assembly, a purpose-built termination piece that connects to the end of the pipeline. The laydown head is the interface between the pipeline and whatever it will connect onto the seabed. A valve, a riser, a tying spool. If the flange connection has a problem, you find out at the seabed, not on the deck. Fixing a problem at the seabed means ROV work or dive operations. Nobody wants that. So it is properly done here. The abandonment and recovery cable, the inner cable, is now connected. As the pipeline goes over the stern and down to the seabed, the weight of the suspended pipe has to be managed carefully. The inner system does that. It takes the load and controls the lowering in a controlled and deliberate way. The cable is connected, the load transfers, and the pipeline begins its final journey over the stern, down the stinger, through the water column, and onto the seabed. The people doing this work do it every day. For them it is a routine, but if you have never seen it before, I hope this video gave you a real sense of what actually goes into building a subsea pipeline. If you found this useful, please like and subscribe. There is a lot more on this channel. See you in the next one.